What strategies have been proposed to mitigate the negative impact of phase transitions in NaMNO2? Could material modifications or doping approaches improve its cycling stability while maintaining favorable electrochemical properties? How does NaMNO2 compare to other sodium-ion cathode materials in terms of phase transition severity and capacity retention? Are there alternative synthesis techniques that could enhance the structural integrity of NaMNO2 and reduce phase-related degradation? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? What role do defects or vacancies within the crystal lattice play in the capacity fading of NaMNO2? Can electrolyte optimization or structural engineering extend the operational lifespan of NaMNO2-based batteries? How do advanced characterization techniques, such as X-ray diffraction or electron microscopy, help in understanding the structural evolution of NaMNO2? What lessons can be learned from other transition metal oxides regarding phase transitions and cycle performance improvements? Are there emerging research directions that focus on overcoming the inherent limitations of NaMNO2 for practical sodium-ion battery applications? How do the charge and discharge curves of Na/NaMNO2 material at C/10 reflect its electrochemical behavior? What specific features in the charge-discharge profiles indicate the stability or instability of NaMNO2 as a cathode material? How does the voltage evolution during charge and discharge cycles reveal the underlying phase transitions in NaMNO2? What mechanisms contribute to the capacity attenuation observed in NaMNO2 over multiple cycles? How does the initial specific capacity compare to the capacity retained after several cycles, and what factors drive this decline? Why does the capacity fade become more pronounced with an increasing number of cycles, and what structural or chemical changes are responsible? How do the charge-discharge curves illustrate the relationship between sodium-ion intercalation and deintercalation processes? What role do voltage plateaus play in understanding the phase transitions occurring within NaMNO2? How does the presence of multiple voltage platforms indicate severe phase transitions, and why is this detrimental to cycling performance? What are the specific phase transition mechanisms occurring in NaMNO2 during charge and discharge cycles? How do these transitions affect sodium-ion diffusion and overall battery efficiency? What structural characteristics of NaMNO2 contribute to the observed voltage platforms? How does the evolution of the crystal structure during cycling impact its stability and specific capacity retention? In what ways does the interaction between sodium and manganese ions influence the electrochemical behavior of NaMNO2? Are there external factors such as temperature, pressure, or electrolyte composition that accelerate phase transitions and further degrade cycle life? What?